right, so I put this graph on here in case we needed to review increasing, decreasing, end behavior, concavity. Anything anybody wants me to go over? You don't have this graph, but concavity. Okay, that's a great plan. Let's just do concavity about this graph, okay? So what would we need to find for concavity? Well, we would need to identify that there's a minimum, maximum, minimum, but that in between those, we'd need to find the inflection points, and those, remember, are estimates. You'd scroll around on your calculator till you were happy. I kind of think we should use maybe 0, 0 as one here, between this max and min. Would that be okay? And between this max and min, I don't know. What do you want to go with? Just pick this one. Close enough? Okay. So our inflection points here are 0, 0 and 2, 8. Okay. So concave up is which section? This is happy, right? And this section is also concave up. Okay, so X intervals where it's concave up. Would be the left of the graph until we got to the X value of 0. And then again, to the right of 2 here. So we'd say also 2 to infinity. Okay? And concave down, where it was sad. Yes, in this little section right here, it was bent down. Okay, is that a good review of concavity for you? Anything else anybody wants me to talk about on that graph? Okay. Can we look at worksheet 7B also as a warm-up today? 7B has 6 matching questions on it. This is the parent function right here. And we are to match these 6 equations to the choices. You will have to do this on the quiz. It doesn't have 6 matches. Okay? It's on the final. It's on the priority portion of the final. It's all over the place, this matching business, okay? So this was the parent over here. This is our f of x, okay? What happened to it to become graph number 1? In words, tell me what happened. This is the parent. This is where it went. So it went to this one. So down something. Okay. Did it just go straight down? I think it did, didn't it? Okay. It looks like this was at 1 and now it's maybe at -3. Okay. So what would down 4 look like? No. Up, down is on the outside and it would be minus, right? But if you look at the choices, I think we're at, yeah, down 5 maybe. We thought 4, but it might be 5. This is not the one on the quiz is a better graph, okay? But that's the best choice for this. It definitely is not flipped over or stretched. It's just shifted down. All right, so let's go with number 2. Can you tell me in words what happened? So I heard flipped, which is the word you're going to use on your quiz, right? Is reflected over which axis? Yes, over the x. So this point went down here and this point went up here. Okay, so it's doing, I don't think that's the only thing it did though. Because if all it did was flip, look at this one. What I just said was if it flipped, it would look like that, right? It would have a piece below. This was the original. If it flipped, it would look like my green one. So what else happened? Yeah, out of the choices, this is just flipped, right? This is just flipped plus 4. So if I took my green one here and shifted it up 4, does that look a little bit more like this one? If we just flipped it, do you understand it would have had points still below the x-axis, right? When you flipped this point right, let me just one more time. If you flip this point that's at, we'll say, -1, 2, if you flipped it across the x, it should be at -1, -2, and it's not anymore. If it was down here and then it moved up 4, that would work. All right, so we're going with A. What about 3? Can anybody tell what's going on? Stretched which way? Okay, so it's stretched vertically this way. Notice that the x-intercepts did not change. It's still crossing x here, here, here. Okay, it used to go up to about what? Maybe 2, and now it's up almost to 6. Okay, we can't really tell how far down it goes because it's cut off. All right, so the y values changed, so it's multiplied onto the whole function. How much do you think it was stretched by? Well, any of these stretches? Okay, this says 3 times the y value. Does that work for going up to 2 and now going up to 6? What about this one? It's goofy, but can you tell what happened? What do you notice about the graph right away? It's all positive. Okay, so what became positive were all the y values, yes? Okay, so absolute value of all the y values made them all positive. Does that work? Need to be memorizing these transformations. All right, number 5. What is C? What is the difference between these two? Okay, this is reflect over y, which would flip it up and down. And this one is reflect over, which would flip it this way. So what do you think? Yeah, I think B. Is everybody okay with that? This point that was at like -1, +2 is now at +1, +2. This point that was at, we'll say 3, -12, I can't tell, is now at -3, -12. Okay, so the x's change sign. And what's happening here? Yes, so this was at -1, +2. It's now at -1, -2. This was at like 3, -12. It's now at 3, +12. So the y's flipped. Just need to take a few, or there's a box back. Okay. Yeah. All right. This is not on the quiz, and I don't want to run out of time today. So, but tell me real fast, how do you do midpoint? Average the x's, average the y's, right? You add and divide. How do you do distance?
Oh yeah, it's the square root.
Yes, you subtract. How far apart are 12 and 4? And how far apart are 5 and -3? So you'd have 64 and 64 is square root of 128, or 64 times 2, so 8 square roots of 2. Equation of the line, what do you have to start with? Good job. So I got a slope of 1. Then could I just pick one of the points and put it in?
Yeah.
So I'd have y equals x minus 7. I don't know, does that work? Check it out. 12 minus 7 is 5, 4 minus 7 is -3, right? All right, so quick review of those concepts. Worksheet 8B. Okay, this is the last assignment. Oh, this is the notes for the last assignment on this week's homework check, the big long homework check number 5 that goes with summative number 5. The concept is transformations, and what we are doing today is identifying the parent function and then writing a transformed equation. Okay. So this is 8B. Everybody find it? All right. So these are numbered, and it uses this horrible dot paper that I tried to make the graph paper on worksheet 10, which is your assignment, a little bit better. It's kind of hard to read these. Okay. Equation number 1 is this U-shaped thingy. Can anybody tell me the parent function? Okay. Y equals x squared. Now, the general transformations that occur, we have y equals, there could be a stretch or a flip. It could shift left or right. It could shift up or down, right? Okay. We know this as vertex form. So for a parabola. So where's the vertex on a plane parabola like y equals x squared? 0, 0. Where is the vertex on this one? Can you tell? That's not what's labeled. It's -3, 0. So how do we put that in? And there'd be nothing on the back, right? So -3, 0 is the vertex now. How do we decide on the stretch? We did this with parabolas already on a quiz. What did you have to do? To plug in another ordered pair. The thing with this dot paper is it's really hard to tell which ones are exactly on ordered pairs. They did label a point we could use here. Okay. We could try a different point, but I'm going to go with this one first, I think, and see. So using this one that they've labeled for us, what should we put in? What's the y value? Isn't it 1/5? 1/5 equals a, and this is the x value we're putting in, -2 plus 3 squared plus 0. That was pretty much a gift, because what do we get? -2 plus 3 squared. So we have 1a equals 1/5. Okay. Can we try maybe, I don't know, what would you have tried that one maybe? -6, 2? I'm going to try that one and see what happens. You don't have to copy this down. We already know it's 1/5, but I just want to check if it would have worked. 2 equals a -6 plus 3 quantity squared. I don't think you get the same answer, do you? Because this is going to be, you're going to get 2/9, not 1/5. I don't know if that one would have. All right, anyway, if they give you an ordered pair, you should probably use that ordered pair. That one is like -8, 5. If I had tried that one, I would have had 5 equals a times -8 plus 3 quantity squared. That would be what? -5 squared. There's 25, right? And then when you would have divided, it would have been 1/5. But how many would have picked that point? I don't know. So we're going with 1/5 x plus 3 squared is the equation of graph number 1. There's copies in the pile there of everything. That one your finger's on right now. Somewhere down in there, there should be another copy if you're missing one. Okay, so equation number 2. Who's the parent function? Yeah, it's just a line, y equals x. But do we need to talk about transformations? Has it been shifted, stretched, left, right, up, down? Can we just write the equation of a line because we're really good at already writing the equation of a line? So what do you think the slope is? Ooh, I think it's ugly. Because if I try to go 2, that's not a dot, right? How about if I go from here, though? One, 2, 3, 4, 5, and left 2, or down 5 and right 2. Is that working? Do it again and make sure it works. Yes? Down 5 and right 2? Okay. And what else do we need to write the equation? The y-intercept, which is looking like 6. So what do you want to write for an equation? Okay. You could write f of x equals, I'm not going to be picky. All right. Who's the parent of number 3? Yes. F of x or y equals absolute value of x. Okay. Where would a stretch go? Or a reflection? Out in front, right? So we're going to have an A, absolute value. What would go inside? Yes, plus or minus if it moves left or right, and on the back would be plus or minus if it moves up or down. Okay, where is it normally have this, I'll call it a vertex point, is normally at 0, 0. So this one has shifted right 5 and up 1, 2, 3, 4. Okay, so where do you want to put those numbers in? Right 5 would be minus, and up 4. And what do we already know about A? Any ideas? It's opening down. It's going to be negative, yeah. Make sure it turns out negative, but we shouldn't have to do that. It should automatically take care of itself. All right, in general, if you can pick a point 1 off of the vertex, that looks like it's at an ordered pair, that would be the easiest one. So we could pick either one of those. Which one do you want to pick? One on the left, is that 4, 1? Okay, so we're going to use 4, 1 to find our stretch. So it will look like what? Okay, so we're putting this in as x and this in as y. 1 equals, okay, 4 minus 5 is -1. Absolute value makes it plus 4 is 5. Is that how I do that? Please tell me no. Okay. Remember, this is multiplied together, but that 4 is not. So this becomes a positive 1A and a plus 4 on the back. So what do we do to get rid of the 4? So we have negative 3 equals A. Anybody think they could have predicted that ahead of time? Is that the slope of this branch right here? Okay, it's going down 3 and over 1, down 3 and over 1, down 3 and over 1. That will always work for a linear absolute value, okay? But just be careful because the slope of this branch over here is positive. You had to know that it was going down. So y equals negative 3 absolute value of x minus 5 plus 4 gave us the equation. All right, number 4. Does anybody know the parent of that one? X cubed. Good job. Okay, so we're doing the same thing. What point are we looking at as being our special? It's not really a vertex anymore, but okay, so it's kind of that inflection point, right? Where it changes its shape. Normally it would be doing this over here, and it would be doing that at 0, 0. It has shifted to the right 4 and down 2. Is that what you just told me? Okay, so how do I put that idea in there? That's not X and Y, guys. That's the shifts. Oh, and it's down 2, right? Okay. Anybody tell me what that looks like? How many of you are confused there? This means right 4 and down 2. We okay? All right. So choose a point to put in. If we can pick one away from there that looks good, that would be great. 5, negative 1. This time I'm going to put that in as my x and y. So I'll have negative 1 equals a. 5 minus 4 cubed minus 2. What does all this become right here? 1a, right? So what happens when I add 2 to both sides? So is there any stretch going on this one? No. It's not stretched or reflected. So far, so good? Okay, number 5 is written out here. Ooh, all over that, right? Square root graph. Okay. The stretch will go out front. Any shift left, right will go inside. Any shift up, down will go on the back. Where is our usual 0, 0 point gone to? It would normally look like this, right? Instead, it's over here. Is everybody agreeing or not? I can't read that paper. Does it say negative 8, negative 6? It's totally messing with my bifocals. Okay, so how do you want to put that in? Left 8 would be, no, it'd be plus. Left 8 and minus 6. Okay, to determine the stretch, can we tell what that point 1 unit away is or not? Or the first point off of the vertex? Okay, so this is x, this is y. So I have negative 3 equals a square roots of negative 7 plus 8 this part right here becomes square root of 1, which is 1 times a, which is just a. Then add 6, and I get a equals 3. So we have y equals 3 square roots of x plus 8 minus 6. How could we check that we did that right? Yep, type it in the calculator. Find x and y intercepts, look at the table, make sure the graph itself. You could set the window to what we have here, right? And see if it's looking right. Okay, number 6, last one, isn't it? Anybody know what that is? Okay, but how do we make that sideways? It's not, yeah, it's the cubed roots. Okay, now we're still going to have a stretch out front, possibly a left-right shift in here, and an up-down shift on the back. The cubed root graph normally looks like this. Let's see. The cubed root of 2 would be 8. It would be way back here. So it normally looks like that. Where did this 0, 0 inflection kind of point switch to? -1, -4? Okay, so down 1, no, left 1, sorry, left 1, down 4. How do I put that in? Left 1 and down 4 on the back. Okay. Can we try, I don't know, we could try that one or that one. Which one do you want to use? Top one or the bottom one? Okay, the bottom one is at 0, -6. Okay, if I put that in, for x and y, I'd have -6 equals a cubed roots of 0 plus 1 minus 4. What is cubed root of 0 plus 1? Cubed root of 1, which is 1, times a is a. So I have -6 equals 1a minus 4, which would make a what? Ah, so Hofbauer's original drawing is totally wrong. No one else yelled at me. I bet Zoe caught it. What's the cubed root of 1, guys?
1.
Cubed root of 8 should be 2. It should have been going this way. My original parent graph. Okay. Because the negative then flipped it, right? All right. So let's try this one on the calculator, just partially because I think some of you don't even know how to try this one on the calculator. Anybody know? Oh, it's not square root, Hofbauer. Well, it's opening. Let me throw the little 3 up there. Okay, go to y equals. How do I find, okay, -2, is that what we got? Then how do I find cube roots? It's in math, but it's the 4th one down. Okay. If you didn't get a little box to type in, then you have to close your parenthesis when you're done cube rooting. What did we end up with in there? X plus 1? And then you arrow to the right to get out of there, or close your parenthesis if you have the older calculator, -4. Okay, it's a standard window. Is that what it looks like? Yeah. It looks like it has a hole, but it doesn't. We could change the window and that might go away. What's another point that looks like something close on your calculator? Should we find the y-intercept? Or the x? Yeah, well, we know that. How about -2? If we do trace -2, my graph is going through -2, -2. Does that look right on your graph paper? -2, -2. Here, this other red dot, right? All right, any questions? So your assignment on this is on worksheet 10. You just have to do the even ones, they're circled. Okay, I want to do a closing activity today on worksheet 9. These are more matching. I did not put this on the homework check. I could have, but instead I thought we could just try them together. This is a really old worksheet, as you can tell, but this is the parent function. Would you like me to put that on the quiz as the piecewise function you have to graph? So it's a line below -10, it's constant, it's got a parabola, it's got an absolute value, it's constant, it's got another line. It's a disaster. Okay. All we have to do is match each one of these questions to one of these equations right here. So talk me through what all these would do real quick. I want to write next to them before we get started. What would this do? This is a huge issue. You all need to be able to tell me this. Yes, stretch which way? No. This is 2 times f of x. Sorry. Yes, it's a vertical stretch by 2. What would be changing? Yes, the y's would change, okay? The x-intercepts where it crosses the x-axis would not change. And this is just the same thing with what? Vertical stretch by 3. Okay, yeah, I can't spell. I'm just going to write. Oh, I got to write stretch, otherwise it's going to look like a shift. Okay, what's going on the next one? Yes, this number is still out here. It is a vertical shrink. But what else? What does the negative do? Reflect over what? So it's going to be upside down and shrunk towards the x-axis, shorter. All right, what about this one? Left, 7. Okay, this is our mortal enemy. Anything inside is what? Opposite of what it seems. So a 2 inside is a horizontal shrink by the reciprocal of this, which would be 1/2. So it's going to take all of the x values, the x-intercepts, and shrink them in by 1/2. But all the y values, the height, bottom and top of the graph, are going to stay the same. All right, what about this one? Yeah, this is really just a 1/2 x, right? Just written x over 2. So it is a horizontal what? Stretch by 2. So it's going to take all the x-intercepts and move them out twice as far, and the top and the bottom values for y will stay the same. All right, what about this one? What can it not have? Yes. No negative what? No, y values. Okay, it's going to flip everything above. This is going to, does anybody remember what an absolute value inside does? It's a really wonky one. Yes, it ends up with y-axis symmetry. And it cuts off all the, yes, okay? eliminates the left side. Cuts off the left side. Oh my goodness. Does anyone know what this would do? It would do this first. What does a negative inside do first? Reflect over what? This is the X. Okay, that's what a negative out front does. A negative inside, reflect over the Y-axis. Then it's going to cut off, after we've reflected, now it's going to cut off everything on the left and make it symmetric. That's a hot mess. We'll find that one eventually. But what about this one? Two things. The order you should tell me is this one first, reflect over. So it's going to flip this way, and then it's going to shift. Good job. Okay, this is an easy one. Two things. This is an easy one. What's happening? This one's right 5 down 6. This one's left 5 down 6. Okay, here we go. Here's the original. Here's A. I put them on the same screen for you. Any ideas? It is a stretch which way? Yes. The zeros are still here and here at around 0 and 10, right? And out here at something. But where this used to go up to maybe 3, it's now going up to maybe what? 8 or something? So we have to decide, is it by 2 or 3? Those were our two choices here, right? Okay. What was this at originally? Can you tell? Down as far as like -6, and is it down to 12? So I think it's only 2. What do you think? 2 f of x? All right, what about this one? Original? It's definitely what? Flipped upside down. Okay, flipped upside down, we have choice of this one or this one. Okay, flipped upside down. This would be shifted down 9. Yeah, that's definitely not down 9, right? So flipped upside down, this used to go up to maybe 4, and now it's only going down to maybe -2. Does that seem like half? So -1/2 f of x. Okay. What about this one? What do you notice? Absolute value. It has no negative x, no negative y's. Which one was no negative y's? Absolute value on the whole thing. Would you figure that one out eventually? Hope so. D. It looks like the left is cut off, but it's just the window, I think. Yeah, I think it's shifted to the left. It could also be shifted up or down. I don't know. What are the options? A left shift would look like this or this, right? So is it left 5 and down 6 or just left 7? All right, E. Which half is missing? They cut off this left half and then did what? Yeah, reflected. What is that called? It's one of the absolute value ones. But remember, we had these two choices. Did they reflect it and then cut it off, or did they just cut it off? Okay. They cut it off before they reflected it, guys. They cut off the left half and then made it symmetric. Okay? That is this one. This one, they reflected it over here. And then did what? Then they cut off the left half and made it symmetric. So they reflected it, then they cut it off and made it symmetric. I don't think I put that one on a quiz, to be brutally honest. All right, what about this one? It's condensed or shrunk what? This way, right? There used to be, this was out at like 12, now it's at 6. This was at like -10, now it's at like -5. Is it the f of 2x or 1/2 x? Okay, but anything inside is the opposite of what it seems. So the 2 is what makes it smaller. All right. Stretched out this way. So that would be the, yes, because this was at is at like 4 or 5. Okay, this one, I don't know. Where are we going? So this was at like 6 and now it's at 12. I don't know. I can't even tell. All right, what about this one? It's definitely upside down. Which ones are my choices? Yep. That work? Upside down and shifted down 9? One more? Oh, this is an easy one. This little thing went from over here, went this way and this way, which is what? I don't think it's on the homework check, is it? All right. Oh, everybody knows what they're doing tonight? Those last questions, and then the homework check will be, you're done, you can turn it in tomorrow. But look at that review tonight too, because I can spend as much or as little time on each section of the review as you need me to tomorrow. I have tons of extra practice built into the review. Yes, I do. Let me stop the recording here.